Hello everyone, my name is Tyler, and today I'm going to show you how to display the attack ranges of your units. This is a continuation from my previous video where I go over unit collision, so if you haven't seen that, there should be a little pop-up right about now that'll direct you to that. Okay, so with that out of the way, we're going to go to our unit GD script, and we're going to add in two variables. This is going to be at export var is underscore weight, set that equal to false. And then right around here, we're going to do at export var attack underscore range, set that equal to 0. Okay, so isWeight is the check to see if a unit is currently in a wait state. And this would be, let's say when you move a unit in Fire Emblem and do an action like attack or use an item, this would be the state that would be put into right after they take the action. Attack underscore range is the distance the unit can attack from their current position. In a later video, we'll need to create a function that will check the currently equipped weapon in our inventory to determine the stat. But for now, we're going to manually set this range. And to do this, we're going to go to our 2D scene. We're going to click on this cat. And as you can see, our attack range is 0. For the cat, we're going to set our attack range to 1. For this bear, we're going to set him to 3. And we're going to set his move range to 0. Let's move him down here real quick. For a squirrel, we're going to set our attack range to 2. And then for our enemies, we're going to set our attack range to 2 for all of them. And then for these two enemies right here, we're going to set them to isWeight. And the reason that we're doing this is for testing purposes later that I'll get into right at the very end. Okay, so now we're going to want to go to the game board script. We're going to want to add a variable called underscore attackable underscore cells. There we go. We're just going to set that to empty array for now. We're going to want to scroll all the way down to Dijkstra's, and we're going to add a bool called Attackable underscore check. Set that bool, and this will break this up here, and we'll just change this to false for now. Scroll down here back to Dijkstra's algorithm, and we're going to want to go to this if check before. So the reason why I tiered my ifs like this instead of combining them is because we're going to be adding onto this with an else if. And we're going to do underscore units at the current coordinates dot is underscore weight and attackable check, and then we're going to do occupied cells dot append coordinates. So essentially now this if, what it does is it checks to see if the tile is occupied by the opposite team or by a weighted unit. The or underscore coordinates dot isWeight is the line that we're going to use to calculate the actual attack range for display and on hover. If you don't care for that, you can remove this line if you do want the attack ranges to always be displayed even if a unit cannot walk to a certain cell, which means that you could skip this next part that I'm going to do, but down here at the bottom we're going to change our return statement by adding filter function I return I not in occupied underscore cells. So once again, to reiterate what we're doing, what's happening now is the return function is going to use a lambda function to remove all the cells by our units that are occupied by units that are in a wait state, in order to show the user the real attack ranges they have with any particular unit when we plug this into getting our attackable cells function. And this is like to say that in the event that a unit can move out of the way, we do want the user to know that it is possible for them to move a different unit and attack versus showing them that it is not possible. And at the very end, I'll be able to clearly show this, but for now we're going to move on to the next part. Okay, so now we're going to want to go all the way up here to our get walkable cells, and we're going to add a new function below it called get_attackable_cells, and we're just going to take in a unit of type unit, and we're going to return an array. Okay, so now we're going to do var attackable_cells is equal to an empty array. Do var real_walkable_cells is equal to _Dijkstra's unit.cell unit.move_range. I'm going to set that to true. And then we're going to do for current_cell and real_walkable cells for current_range and range of 1 to the unit.attack range +1 attackable_cells is equal to attackable_cells plus flood_fill current_cell unit.attack_range. And then we're going to return attackable_cells.filter function I return I not in real walkable cells. All right, and essentially this is the function that will return an array of cells a given unit can attack using Dijkstra's and flood fill algorithm. Okay, before I forget, we need to now go to our flood fill algorithm. We're going to rename this to full array because I believe this is more appropriate. And then we're going to do var walls_array, or see here, yeah, wall array, set that equal to an empty function. And then we just need to change all of these tiny little errors real quick to full array. Let's see here. And then _var coordinates. We need to do if _map.get_cell source_id 0 coordinates, set that equal to obstacle_@list_id, and then we do wall_array.append coordinates, and obstacle atlas ID not declared within the current scope. Let's see here. Where am I calling this? Oh, I see. I forgot to add a constant variable all the way up here. constant obstacle underscore atlas underscore ID equal to 2. So essentially the reason I'm doing this is because within our tile sets, the IDs that have 2 are walls. So I'm just designating that ID to forever be like walls so that we don't ever calculate them. So we don't show them whenever we start drawing stuff out onto the board. Now if I go back to the flood fill algorithm. So yeah, what this if does is that it detects the impassable objects we've defined, and if you don't want units to attack over walls and you only want them to like move around a wall to have to attack, you can comment out the append statement and just change it to a continue. And speaking of continue, we need to remove this bit of code right here, and I'm just going to comment it out for now. But the reason we're removing this is that this is detecting every cell that is occupied as a unit as something that we cannot draw attack ranges on, which is incorrect because we actually do want to do that. And now for our return statement, we're going to add a lambda function, another filter, and we're going to do function I return I not in wall underscore array. And so the reason for this is we're drawing out the attack ranges, disregarding that walls exist, right? But at the very end, we need to remove every cell that was a wall or an impassable tile. So that way we can actually tell the user like, hey, you can't attack this wall, but you can attack past it, right? And that's what I meant by adding a continue here. Because if you put a continue here, then we won't show the user that they can attack past it in a wall or impassable tile. Okay, so now we need to go and create our draw function. And we're going to go to unitpath.gd. Apologies, we're going to go to unit overlay, which I believe is down here, unit overlay.gd. And you see how we already have a draw function right here? We're actually going to be renaming this draw function to draw underscore walkable underscore cells. And then we're going to be making a new function called function draw underscore attackable underscore cells. And it's going to do cells array, and it is going to return void. We don't want to do clear. We're not going to do clear here because that would wipe out all of our walkable cells, which we don't want it to do. So we're going to do for cell in cells. We're going to do set underscore cell to 0 cell 1 and then vector 2i 0 0. Okay, so this is going to be x, y, z, and then I. Z is really important here because Z indicates the ID number in unit underscore overlay tile set to essentially determine what it's going to draw. And we're going to want to edit this because we now need one that is of Atlas ID 2, right? So we're going to open this up, and you can see that we have the old one. Okay, so I've removed the yellow tile that used to be here, and I've put in a blue and a red one, and I've changed the blue one to be of Atlas ID 0, and then the red one to be of Atlas ID 1. We'll want to get rid of this clear statement right here then. Go to our game board GD, move this down. We want to look at our error on 201. You'll probably be all the way up here. You just click there, go automatically to it. Then And we're going to want to make two little sections here. And then under walkable cells, we're going to do attackable cells equal to get attackable cells active underscore unit. And then we're going to do above this underscore unit overlay dot draw attackable cells attackable cells. Save that. Then this one will be draw walkable cells. And then these are just two little sections. We want to draw our attackable cells first because this is going to lay out like a whole array, and it's going to include the cells that we can walk on. And then we're just going to draw a different color on top of the cells that we can walk on in reality. I could show you what this means, because as you can see, we have it normal, right? But if we change the order here, we would get red, like right there, where we have like a weighted unit, which we don't want to do, right? Just undo that. Save. And yeah, there we go. We now display the attack ranges correctly of all of our units. See, like this, we could see that we could attack over the walls. We could see that our range goes to 1, 2, 3, 1, 2, 3, 1, 2, doesn't go over the wall. If we move our unit over here, we could see that we could attack 2 away. If we move him down, you could see that it goes over and over. Now, for checking if the is weighted units, let's move this guy right here. You can see he can attack past it. He can attack up to here, right? He can't attack here because since this unit is weighted, he cannot move to this tile and he can only attack from here. So the attack range is correct by displaying right there. If we look at this guy, you can see he can't attack at all because these two units are weighted and they can't move out of the way. But if I were to move this guy here, you can see that this changes. If I were to move this guy here, you could see that that changes because then we can move him away. And there you go. We have it to where the attack range is displayed correctly based on if our team members are waiting, if they're not, and based on how far we have the range so that we could see that we could attack over walls and over enemies as well. And with that, that'll be the end of the video. If you have any questions, comments, or concerns, please let me know in the comments. Please like and subscribe to show support, and I hope you have a wonderful day.